Well, welcome to the afternoon slot. Hello, everybody. And I'm Richard Baker, and I'm really looking forward to the conversation we're about to unfold. So let me first kick off by welcoming a really impressive and esteemed panel. So I'm going to invite each of my colleagues here to introduce themselves, but we're here to talk about building the machine-to-machine based Internet of Value. And this is a conversation that will take us, I think, through a journey of infrastructure, and we will explore use cases, and we will explore protocols and standards, but we're going to try and keep it a little animated and tangible as well, and I'll context it a bit more in a second. But firstly, may I invite from the far end, Owen, please, would you mind introducing yourself?
Hi, yeah, my name's Dr. Owen Vaughan. I've been doing blockchain research for the last 6 years. It's really foundational research. It's kind of scientific in nature. We're trying to really get the most out of blockchain functionality by adding additional features and making it relevant to new use cases. And in particular, in this discussion, things like IoT. But my background is really coming from maths and the digital world. And so I'm kind of coming from a purely theoretical point of view, touching upon physical infrastructure, where these guys are the experts.
And Adam.
Yes, thank you. So my name is Adam Feiler, and I'm Head of Partnerships at Minima. And Minima is a layer 1 blockchain protocol that is compact enough to run in full on mobile and IoT devices. So it's a UTXO model, but critically, Minima runs without the need of miners or stakers to validate the blocks. Instead, everyone who runs a node runs a full validating and constructing node, and therefore we all contribute to securing the chain. So our key feature really is that we can become embedded blockchain technology in devices and relevant for machines.
Yeah, fantastic business. Thank you. And Patrik, welcome.
Thank you. My name is Patrik. I have an automotive and blockchain consulting company. I have a permanent contract with Volvo Cars since almost 2 years ago, and I'm an operations lead and technical driver for base class system design. And I also I'm a board member of a blockchain education program in the Swedish Media Institute. And I also work with a couple of layer 1s as an automotive blockchain advisor.
Fantastic. And when I first met Patrik and you described yourselves as the technical driver, as that hybrid role,
sure. Yeah.
I got excited thinking you had the joy of driving Volvo autonomous vehicles, but you get to lead all the technology, all the infrastructure that's behind it.
Yeah, that's correct. So I am not the technical driver driving the car, but I drive the technical aspects of the work forward in the organization, communicating and driving the technical aspects of the common base technologies that the car will incorporate.
Beautiful. Okay, so let's set the scene, and then we're going to unpack this as much as we can. So what we're really talking about, what is the machine-to-machine economy? What's the Internet of Value for that machine environment? So what we're talking about is, we've all listened to many stories now about Internet of Things emerging around the world, so the concept of an edge device connecting to the network. So these machines, these Internet of Things devices, are now something in the order of 15 billion internet-connected devices, and the forecasts still are huge for in excess of 90 billion devices over the years to come. So every part of society is slowly moving to being hyper-connected. And I think as we're hearing in some of the other panels, of course, when I've got a hyper-connected digital environment, this is a persistent data architecture. These devices are communicating to themselves and within different communication protocols and within different environments, and are producing some background data sets that become very meaningful into the future. So we might see use cases such as smart cities, where we've got automated or highly connected streetlights, but road gantry systems. There's embedded IoT within the concrete in the roads. And these things are the background machine-to-machine devices. And we're going to unpack what do those devices today and into the future require from a machine-to-machine architecture, and where is the value exchange for those devices over time. And so let's kick off with that, because I feel that in order for these environments to be really meaningful for citizens and for society into the future, we've got to really look at standards and the role of interoperability. And I think maybe if we could start with you, Owen, in terms of, we've got the backbone of the planet is really a TCP/IP network. Mm-hmm. And we've got the concept of blockchain technology coming in and participating in this already fairly well-established standard and this important transport communication protocol. Mm-hmm. And so I'm going to proffer a concept saying, well, why is it taking so long for something like the Bitcoin protocol, as an example, to not just be overlaid in the OSI data architecture and say, well, I'm just a transaction communication protocol. My job is to facilitate the transactions on top of an IP network. So what are we talking about when we think about how value exchange is going to happen at an embedded network layer?
Okay, I think it's a deep question, and I think I'd like to start by explaining how we got here in terms of the evolution of the internet and how it's relevant for machines, and then talk about where the role of blockchain sits in the typical tech stack from the physical transport application layers and so on. So when we talk about machine-to-machine networks and IoT devices, we use words like the Internet of Value or machine-to-machine networks, or another way of thinking about it is Web3. And I don't think we have those generations that we do in the web that we have in the physical infrastructure. But I think it's useful to step through that and see why the physical world links up at the generation 3. So, and it will also tell you a bit about how the interactions and the security work. So Web 1 was really the experience you had in the internet in the 90s. So it was something like the websites you went to were read-only. There was lots of useful information there, things like Wikipedia and things like that, where it would typically be one person or one organization produces a website, you go there for some content. Web 2 is really, from the kind of 2000s onwards, it's more of an interactive experience. So it's these social media platforms, things like Twitter, Facebook, and all that. They're characterized by very large players. So we know that things like Google, for example, Amazon. And there's a benefit to that. We have great user experience. Even now, I don't have to remember any passwords because I use my Google Password Manager to log into everything. So there's a lot of benefits that came with Web 2, but the price we paid really is in two ways. One is we lose a lot of control over our own data, and in particular, importability. So if I want to move from one social network to another, I have to create a new account, start my new history of photos, etc. I can't just move from one to the other. There's no incentive for those companies to do that. And secondly, it's in terms of security. So now it's incredibly difficult to build a website. An amateur can't build a website now that won't be immediately hackable. So there's a very high barrier to producing any services or quality in Web 2. But now in Web 3, it's a much more decentralized experience. It's still at this stage of vision of where we want to get to. In the digital world, it means things like me being able to manage my own identity and then allow an online platform to use the fact that I'm over 18 but not my actual age. Or maybe I can connect directly to Richard and we can start communicating or maybe transacting. And it also starts to bring in the physical world as well. So now we have IoT devices, particularly home devices are really I think they really are forcing us to confront Web 3. We have an interconnected web of devices communicating over the internet protocol that desperately want to be connected with us. And I think because they don't contain much sensitive information or big databases, it's very easy for us to be connected with everything in our home. We have very good protocols like Bluetooth and Wi-Fi and things like that. But we're seeing now, still in terms of physical machines, things like driverless cars, they're still, I think, a kind of Web 2 model. We're locked into a few big players, and at the moment they're pursuing their own ways of doing things independently of one another.
I think that's an important point as well, Owen, because I think the journey that we have with blockchain technology, some of the Web3 technologies, is we're seeing effectively different protocols competing, we're seeing different application stacks.
Yeah.
And maybe that's part of the innovation journey, that's just the phase of this industry. But maybe I'd like to bridge here and say, Adam, when you went about the design strategy for Minima, you are also, I think, bringing this IoT powered and a new concept for how the mining side of a UTXO protocol will work. But you're bumping into a buzzword that's in your industry now called Deepin. So what is Deepin, and what does it mean for the IoT embedded connected world that we're talking about here?
Yes. So Deepin, decentralized physical infrastructure network. It's a term that was being coined about 18 months ago, and it is an amalgamation of a few concepts where people are trying to encapsulate the concept that you've got a physical hardware that can provide a service, and then you've got services that this hardware can provide, and there are people who are prepared to pay for this service in a purely decentralized infrastructure. And it's an interest, it follows very much the pattern that Web3 is taking as a resistance to Web2. And this idea that we don't need big tech companies just to take entire control of our data. So it's can we almost replicate the single company, large big tech model in terms of the functionality of, and I'll explain the use cases in a second, and can we actually distribute that hardware between users? And so Deepin is being tested now in a number of areas where we say, okay, people can own, for example, their own mobile hotspot router at home, and we can tokenize this, and people can pay micropayments for the use of that hotspot for the time that they're using it. So it's a very powerful concept, and it does encompass a lot of use cases, which we can delve into.
Yeah.
But what's interesting about the whole field now is it's quite inclusive, and it's giving people the realization that rather than use one blockchain entirely for an application, we can use bits of technology and have a much richer stack. So yeah, so it's an interesting topic.
Exciting. So I think this paves the way for my next big purchase, I think, Patrik, which is I need to buy a new car soon. So will that car be a Volvo connected autonomous vehicle? And aren't these cars just really big sensors on wheels? What's going on in a modern connected autonomous vehicle from a telematics point of view? What's happening data-wise?
Oh, so much right now. So think of it as a big smartphone. So you will. As a big smartphone.
Oh, so I'm just driving a big smartphone.
You're driving a smartphone, essentially.
Right, okay.
So you take your smartphone, iPhone, Android phone with you as a key, and you take yourself as a sensor and put yourself into the car.
Okay, that's a good analogy. I can relate to that.
And you interface with the car, and the car will get all the data from you, about you, and all your sensor activity, and it will use that to give you the best possible experience when you drive your car. Or watch your media while the car is driving itself, etc. So that's where we're heading right now.
Yep. So then when we think about putting these things together, so we've got the concept of Web3 and the promise of I own my own data. I can monetize my own data, through my public key to different service providers. One of those service providers will be Volvo, presumably.
Yeah.
Into the future, I might just join the car club and I'd like a different kind of vehicle depending on my mood and my experience. And so am I subscribing through a Web3 experience to the connected autonomous vehicle? So I guess still on the theme of, do we really have the connectivity and standards interoperability in place to allow the emergence of that experience? And how is the data from the vehicle thought about when I log in temporarily to the vehicle? So I'm a moment-in-time user of a particular vehicle, but I just want to stick here for a second before you jump in, Owen, which is, there's a telematics box in the car, there's an eSIM in the car. Who owns that data? Is it me because I use the car, or is it Volvo? How do we think about that?
Well, it depends. You should always read the terms and conditions and rights, right? So usually you just scroll through and then you tick the box and say, okay, let's access the vehicle or anything. So you have to read the blueprint. But essentially, you own the data if you do not give anyone else permission to use the data for specific purposes.
Got it. So there's going to be a permissioning layer within that.
Yes, of course. And then all the future connected vehicles with autonomous drive do have multi-signature access and authorization. So that means that either you can use yourself, your biometrics, or you can use your phone as a secondary key to access the vehicle and its services.
Very good. Very good. So maybe, Adam, maybe you could jump in on that one, which is, so have we just heard there's a pretty powerful use case for the Deepin network in terms of that background micropayments architecture or that value exchange that's happening with that experience? How do you think about that?
Yeah, well, I mean, I think that is one key metric to Deepin, which is paying for the value that it provides. So, I mean, some very relevant use cases is distributed compute. So file storage in the cloud, computing in the cloud is basically the ability to use either latent compute or people's hardware as a collective, all contributing to a very distributed and therefore resilient database. And so we're working actually in the automotive space quite a lot, and one of our focuses is EV charging.
Yep.
And the idea for private wallbox owners to rent their wallbox to other EV owners and get paid for that service. So it is a fully decentralized infrastructure where the private wallboxes become part of the public charging network. And so this is really bridging the gap, because there's not enough public charging points today to even meet the demands of electric vehicles on the road. And so to meet the demand and the expected amount of EV cars that are going to come on the road in the next 10 years, we need to massively improve the charging infrastructure. So here is a nice example of a distributed network where everybody can benefit from the collective, and then you can build in payments. And so the tokenization allows a machine payment to be made. And I think that is really where this technology is taking us, because you can allow machines to pay for their own service.
Yep.
And so then the next step is embedding in cars, where cars will pay for their own access rights to tolls, to payments.
Exactly. So we'll come to tokenization a little bit in more detail in a second, but so let's just stick here with, we've got this machine-to-machine communication layer, and I think this kind of takes us into the boundary of some of the Web3 IoT standards that are being developed. So when we've now just expressed use cases about the car with an identity, Owen, as well as the human with an identity, and that's a symbiotic relationship, but it's a bit ethereal, it's nomadic as well over time. So how do you feel blockchain standards for identity all the way up to that Web3 experience, how do you find that evolving, and how ready are we to power that experience?
Yeah, I think it's a good point to bring in the word identity, because when I was listening to your the situation about buying a new car, and you described very well a car.
I haven't told my wife that yet, by the way, but
a car like a mobile phone, which I think is a great analogy. But what was, I think, missing there was you still see the human as a user of that phone, where we need to bring in the user as having an identity in their own right, and the car they're a user of my identity. So we're now, we don't think of, we think of ourselves as organic beings, but we do have a digital presence as well. And so when I get in that car, the car is sensing me, but I'm sensing the car as well. And I might want to, I might want to take that history of being in the car with me. That might be important so I can, I don't know, show where I've been, or that I might have the right to use that car or something like that. And when we talking about human identity and sharing that information, privacy is a massive concern. So that's something that me and my team look into a lot. And I'm quite interested in being able to prove to certain people who I am without them being able to share that data onwards. But where it gets quite interesting is in this relationship between machines and humans with their own identity. I mean, AI is where it gets really blurred, right? Identity for AI. These relationships don't exist for a long time. Maybe I go in the same car a lot, but if I have two cars passing one another very quickly, they have a very quick interaction. It's very important that they're speaking the same language in terms of in terms of standards. But that's where something like a blockchain is really interesting, because it's something that if I design a car to interact with other cars, I might decide I don't want anything to do with the blockchain. It's too unusual for me. But that doesn't mean the other car might not be recording everything you do on a blockchain. And so you better pay attention, and you're going to find yourself in a much better position if you are if you're ready to use this fantastic tool, because in an interaction that is ephemeral, meaning it comes and goes in the blink of an eye, the blockchain is a digital reference of permanence. I would think about it as like a big stone obelisk that's recording any information I give to it. And in that context, it acts more like an oracle. So if in the future we ever need to come back to that event, maybe something happened, and we need to find out what really was the sequence of events, we have this symbol of permanence and immutability in a digital world. And that's why I don't like to think about a blockchain in terms of the tech stack necessarily. So let me walk you down the tech stack and explain how it's relevant everywhere. So you might think of it at the application layer at the top, right? It's a payment mechanism, or it's some type of control system, perhaps. But then we talk about TCP/IP as the protocol for delivering messages. Well, blockchain, of course, works on TCP/IP. I mean, most blockchain transactions are over the internet. But it also works if you don't have TCP/IP. So you might be a system of low-powered IoT devices in a farm that's using a different type of communication protocol like Zigbee. Blockchain still works there. So in some sense, it's agnostic of TCP/IP. You could even consider the blockchain as the medium of messages themselves. Why not? I just create a blockchain transaction. So it can even replace that. Also at the physical layer. So let's walk through this. Now most devices have a secure enclave in where you can secure private keys. Usually we think of this as private keys creating a blockchain transaction, having an on-chain form of identity. But they can also be used to generate IP addresses, specifically IPv6 addresses. So now I have a physical root, the hardware security module in my phone that is really physical. It can't be hacked. It's a hardware security module. And it links that physical device to the blockchain and to an IP address. So the blockchain can be linked to the physical world as well. That's why I think its position in the stack is not so helpful. Instead, we can think about it as an environmental affordance. So we're in a digital world, and suddenly we now have this thing called the blockchain. And that's why I think what you're doing very well with Minima is having that model.
Well, I think you've kindly laid out architecturally perhaps some of the design considerations for a vehicle-to-vehicle environment. So in the assessments you're doing, Patrik, and the technical delivery, when you go up and down that vehicle-to-vehicle infrastructure, what are the design principles? What are some of the considerations that you've been working through?
Well, first of all, you need to have first you need to have safety and reliability, interoperability, and scalability.
Yeah.
For it to be able to support a sector like the automotive sector. So,
what do you mean by safety, out of interest? I understand the concept of safety for a vehicle.
Safety, that means so you can, whenever the cars until today or just the last couple of years has been a closed network, right? We never interfaced with the outside world in the terms of we are doing today.
Yep.
Connected vehicles, and then you need to have and enforce strong encryption. So with enough key length to make sure.
Yes, exactly.
And then also you need to have low latency. And together with that, you have safety and reliability, because everything is about timing.
Yep.
And then you need low latency, hence 5G and the rollout of connected vehicles.
And how do you think about the comment Owen's made there, which is, when I'm on the school run in the morning and my Volvo is passing another vehicle, and that ethereal moment in time communication between the vehicles, that communication is non-persistent.
Yeah.
But we've just exchanged a lot of important data.
Yes.
But as I finish my day and I get home, presumably my black box is uploading to the cloud.
Yes, correct.
All of my telematics are being handed over. So
yes, correctly. And yeah, good you said the black box. So since last year we have European regulations in that comes into play, and it's global. Everyone handles them differently, but in Europe we like to regulate.
Yes.
So data recorders, as we know them, black box, but for connected automotive vehicles are now regulated. And those black boxes contains all event data.
Yeah.
That is predefined by regulatory context. So it should be incidents, accidents, and then you also have different layers of how important they are. It can be that the vehicles communicate the brief moment they met that Owen talked about. The BMW wanted to communicate to the Volvo car. He wanted to say, hey, just 200 meters ahead, I lost traction of my wheels because it was some ice on the road.
Yes.
So be careful. So that kind of data will be exchanged vehicle to vehicle to give you a more safer trip, so safety, and also more convenient. And so what we did with this, I'm also a freelancer and independent contractor also as well. So I almost researched most of the compatible layer 1 blockchains in the automotive, wants to come into the automotive domain. And we did a proof of concept on which can meet the requirements of the embedded systems that is used in the automotive industry. And those are always measured upon different KPIs, such as how much CPU load they take. So we benchmark it, and then we have memory constraints in an embedded system. So from that, and Minima was one of those.
Fantastic. It's a great conversation. I often think, with the greatest respect, I think with the crypto journey that blockchain has been seen, it's a great use case, but it was one lens into the technology. And I think there's just so much more. We don't often talk about embedded design principles, and it's really exciting to be talking about this technology at this depth.
Yes.
Architecturally, it's a different use case and it's a different set of needs. So I'm delighted to hear the experience you've had together. So I think maybe for Minima then, Adam, are you seeing the opportunity to go all the way and say, okay, the car it's a real world asset, is it being tokenized, and where does this take us in terms of building that medium exchange? The background communications and sharing data is one thing, but actually surely the opportunity now for value exchange is quite immense in these vehicle-to-vehicle connected architectures.
Absolutely. So yes, real world asset is another one of these buzzwords that has just turned up, and I think most people understand the real world asset in terms of tangible physical objects that have been that you can tokenize or you can digitize. But in terms of components and the entire supply chain, digital twin was a concept that is now found application in industry, and I think the idea that for every component, for every piece of infrastructure, you can have a digital identity connected with it, suddenly means that you've got the value of this very connected environment, infrastructure. It brings resilience and robustness into the network of connected things. And so regarding the value that item can bring, you can suddenly put individual value on a particular component. So I think that this is a very important distinction between real-world assets and, in this case, physical infrastructure.
Yeah.
Because now you actually put the value on the piece of hardware that is providing the service for that service. Yeah.
Yeah, and I think in my reading of Deepin, we're certainly seeing the telco industry and government infrastructure also playing in that space. I think I've seen, I won't name names, but I've seen some very large group mobile operators actually starting to look at the principles of, well, I'll tokenize my 5G base station and I'll tokenize the tower.
Yes.
And they want a better return on those assets through tokenizing, but they also want those assets to participate in this new connected infrastructure in a different way.
Yes.
And so I think we're at the brink of a very, I think if we were talking through the lens of machine learning and AI, are we about to see a brand new language model emerge? If everything physical gets tokenized and is persisting data, my goodness me, we've got an astonishing learning environment for the world.
Absolutely. And the value actually can be quantified. So there's a very interesting concept of individuals providing mobile connectivity. And there's two companies that we're working on. One is in Africa called Ycrypt, and another one in South America called Wayru. And they are providing internet hotspots in very either rural areas or very poor, deprived areas in South America. And they've provided these hotspots, and people are able not to only educate themselves, but also to earn income generated through buying and selling online. And they can actually quantifiably measure the improvement in the economy, the education, and sort of the general well-being of a society by the value of providing this shared internet, which provides connectivity. So I think that feeds very well into can you actually put a value on this on this ability to very easily deploy a communication network. So from people's perspective, you can actually put a physical amount to it. In terms of vehicle to vehicle, I mean, this is going to be the backbone of communication. If you are having two cars driving on autonomous driving, and then one of them makes a mistake, everybody wants to point the finger of blame. So in terms of litigation, it's no longer a grey zone. You can actually say, well, this algorithm was the one that's responsible. So you do put an element of responsibility on the quality of the algorithm or the digital service.
Yep. Well, and I think that opens up a whole new field. We've always got to remember that in the automotive industry, it's easy to think about the build of the car, but actually the minute the car goes to the retailer and out to the consumer, there's a whole rich ecosystem of the insurer, the breakdown, the servicing. So that there's a rich ecosystem that goes around that. But I think when we're talking in such autonomous language into the future between the infrastructure and the vehicle, in the event of an accident and I'm a partial owner of a vehicle or I've temporarily logged in, so who do I sue?
Yeah.
I think where does this lead us in terms of the identity shared relationship, which is I will have to presumably be in a modern insurance contract where it's a moment-in-time insurance policy for that vehicle. And I'm sure the vehicle manufacturers are thinking about a whole host of new packaging. But how do we think about sharing identity in that kind of use case, maybe, Owen?
Yeah, well, firstly, I wanted to ask Adam a question as someone who's developing a blockchain for the decentralized physical infrastructure, and particularly smart cities and things like that. I see two use cases, really. One is something like payments, and let's say a more accurate way of charging for the things you use. And the other is what we were just talking about, like dispute resolution and safety.
Right.
And which do you see already? Do you see them as being equal utility in the blockchain you're providing, or is one of those more interesting than the other? I'm wondering what the killer use case is there.
Right. Yeah. So I would say, interestingly, most people think blockchain is about payments, cryptocurrency payments. We are actually moving away from that, and we're leaving the payments to be handled by payments operators.
Yeah.
And I think that our vision there is the token just simply acts as a receipt for payment. It doesn't actually represent, it isn't the payment mechanism itself.
Yep.
So I think it's more the latter case where actually it is the communication rails, it is the handshake, if you like, to say, I'm doing something online, and this is my identity. It's private, it's secure, but I'm a physical object. So I think that's the way it is going here. For smart cities, and in general, this data lake that we're adding to, that in itself is going to have the intrinsic value.
Yeah, that doesn't surprise me in the slightest, because I think whenever we're trying to think about how to use blockchain in a certain context, I often see this progression from, okay, firstly, interesting payment system, programmable money, that's cool. Okay, but maybe more interesting is the tokenization of assets and receipts and things like that. But then I think that meme where it's got like a good idea, great idea, and then like the brain's exploding. I think like the best and most complex, let's say, use of blockchain is something getting towards identity of machines, and that's like multiple tokens used together. And I think it's becoming more and more relevant in the case of AI. Maybe it's a good point to bring that in, because at the moment we're all familiar with ChatGPT and similar large language models, but these are big centralized systems. All of the data and processing is done in a data center somewhere. There's just one instance of ChatGPT really that I can ask questions to. But I think as the technology progresses, that will move to what we call the edge, which means computation on, let's say, my local machine or in my local car. And then it starts to become, when that car starts making decisions, we need a way to know why did they make that decision, because it's no longer on our server somewhere. And that's where something like an identity that we know how it's been trained, we know why it's made a decision. Actually, that's a non-trivial thing. Even the people who create these AI models, it makes a decision and they have no idea why it made that decision. It's called AI explainability. So I think when we start moving our AI instances onto local machines that are more closed environments, you need something to counterbalance that. So what really did happen? And that's where something like I think a blockchain can play a role.
Yep, definitely. Yeah, I think you'll want to go back to the trusted record, and you'll want the audit trail of what led to that decision. And so we've got some interesting data analytics environments emerging to help us get to those decisions for the future. And so maybe that's an interesting segue into, it feels like we have the foundation of blockchain technology converging with other technologies through standards and the development of standards. It certainly sounds like there's a bit of a harmony between some of the application experiences that a connected autonomous vehicle in a connected environment might be bringing to us. But we've still got a long way to go to get digital identity, authentication, to really be fulfilling the service experience. So maybe from here, in the minutes we've got left, let's jump to the future. We'll start with you, Owen. So we've come through the standards, but where do you call a prediction for the next 5-10 years in where will blockchain technology end up, do you think? Where is it going to finally rest? Will we be talking like this about blockchain in 5 years?
Maybe I'll kind of answer that in terms of standards, because I think in my mind, there's really two ways that standards can be produced. One is either we discuss together what are our problems, our requirements, and agree a set of standards by committee. And the other is there just becomes one standard that's so dominant, everyone just adopts that because it's easier. I think in the case of autonomous vehicles, probably in the case of identity, this kind of committee approach will win out. We already see things like W3C that are trying very hard to establish a set of identity standards compatible with Web3. We really like them at nChain. I think the blockchain space is a lot more adversarial, so I suspect we'll see one dominant blockchain win out, and those standards will be adopted. So other predictions for the future. I think one thing that there is still a big piece missing of the puzzle in my mind, which is linking physical location cryptographically to digital world. We're all used to using GPS, so it's a passive technology, so we receive the signals and I can work out exactly where I am. But I can't use that after the fact to prove to any of you that I really was here. It's not cryptographically secure in that sense. So we need to introduce some new technology, some maybe anchor points and things like that, so we can really prove where we were at any one time. I'm not even sure if that's 5 years away, but I think we'll start realizing that that's a key part of the problem.
Yeah, I agree. I agree. Yeah, there's some exciting work going on that in central government in the UK on the future of GPS, but we won't cover that today. So maybe down here then, Patrik, same question. So when we think about connected autonomous vehicles, and probably not fair to talk about them on their own, we need to talk about the vehicle-to-vehicle infrastructure that needs to be there to support them. Where do you think we're going to be in 5 to 10 years?
Oh, that's an interesting question.
And maybe also animate, what's the experience for me when I'm in that world? What's the value experience?
First of all, I can say you're going to interface through the car's infotainment system, essentially the screen you see in the middle. So you interface, everything's going to look like an iPad in an iPad, essentially. And you will interface with what's happening within the car and outside of the car. So all your digital payments, automated toll gate payments, parking, even the autonomous shuttles that come and recharge your car when you're in a traffic jam or anything can be automated. And also decentralized wallet integrations in the infotainment system is underway. But just to capture the blockchain part of it and within the automotive industry, that is quite interesting. So when I researched all the many layer 1 blockchains and their compatibility in automotive, Minima was why it's so fun that Minima is here today is because they were the only ones that were able to run a full node on the edge in an embedded system. And to see that kind of maturity, that you can run a node with small memory and computational footprints, that is quite, that leaves a kind of a verification that, okay, blockchain is ready to live on the edge, also in a car. And for your convenience in the car is, you will own the data. You can give permission to sell your data, tokenize your data, or get incentives of your data when you share it with third parties. Possibilities are endless. It depends on who builds what.
Definitely, and we were anecdotally talking backstage about experimentation with other car manufacturers who've got programmable paint. Yeah. And the part of that value exchange is I'll be in my vehicle and my mood will change and I can program the outside of my car to go red because I'm angry. And it'll give a whole new level of road rage. I can communicate my emotions.
If you gave permission to share that with
If I give permission.
Yeah.
So what a flattering endorsement of Minima. Amazing to hear. So same, Adam, you've given a really good insight to the early look and feel of Deepin, and your embedded architecture is really impressive. We've certainly, in my experience coming through these conferences, we've not talked at that level of the mining infrastructure being so over-engineered to run on device and be embedded the way you have. So where is your 5-year to 10-year prediction for this embedded architecture?
Right. Well, we were very proud to announce the fact that we could run in full on mobile phones. But actually, I'm even more excited to announce here that we are going all the way to embedded systems. So Minima is partnering with a chip manufacturer, and we will actually produce a microsystem where Minima runs in full on a chip, and that means massive efficiency, and truly you can get data attestation, you can get verified communication at the machine level. So that really will be a vision for the future and a game changer.
Yeah, amazing. Wow, fantastic. That's a great achievement. Well, we have, I think, all the ingredients for a connected world to be actually delivering a really high value experience for us all. So I'm going to end us here. I really thank you all for your really high value and rich contributions to this discussion. I did pause earlier when I did a session to see if there was any questions in the audience. I don't think we necessarily got the mics out, but I will do it anyway. Let's take a couple of minutes and see if there's any questions on this very, very rich conversation.
Hello. Do you hear me?
Yes.
Okay, so just quickly, in the case of a network of autonomous machines, what is the value of a standards communication protocol? And what options do we have? And is it necessary for my fridge to speak the same language as my power bank, as the ATM, as the traffic light? Thank you.
Thank you. Great question.
Yeah. Do you want to take this?
Well, of course, standards is the A and Z in the whole conversation. As in the real world, if we don't speak the same language, we will sooner or later have a misunderstanding. And when we speak about when we have a connected car that drives itself, and if I misunderstand your language, and the analogy is your language is that you are a phone on the crosswalk and I misunderstand you, I will drive over you. Then we have a problem, obviously. So standards and a protocol of standards that work together, so we know that everything is, we speak the same language on every layer, every point, in any given situations, and all corner cases are handled. We are now battling in the autonomous drive and self-driving cars is we have to actually pre-program the autonomous drive unit and our AI agent that if the car have the two cases, this is quite famous case, if it has, let's say, a mother and a daughter or son, a kid, and then you have two elderly people, which you have the only two cases that the computation says which one should I actually run over. And you have to, this has to be defined. So, and that comes back to we just need to speak the same language. Everything is of importance, and that leaves everything should be standardized, and it should be interfaced with all other protocols by one interface and one interface only.
No, it's a great question, and I think we've absolutely got the foundation for this. I always make this simple in my own mind, which is, you know, layer 4, OSI, TCP/IP, it's the communication protocol layer. I don't expect that layer to deliver me my RTSP video stream when I turn on Netflix. You know, there is a reason there's a 7-layer model, and we expect certain protocols to function in certain layers. And I think we mix things up a lot in the blockchain space, but I think we are slowly demystifying, you know, when I'm handshaking for a peer-to-peer transaction and I'm exchanging value, which part of the architecture over time am I going to expect that from? And it's appropriate to say, yeah, my Zigbee-powered device versus my Bluetooth-powered device, it's okay, we can have different communication mediums to undertake different roles, but there is interoperability across those data sets and those handshakes that will be required over time.
Yeah, I think we should take a step back because what's more interesting is not the language that these devices speak in the different contexts. It's coming from the same root, that it's the same person or the same cryptographic seed that can go to two different standards. One might be a signature on Bitcoin and the other might be IPv6 or something like that. The same person logs into Netflix owns the private key for this TCP address.
Cool. Thank you for that question. Unfortunately, I'm going to wrap us up. Thank you very much for listening and enduring this panel. Thank you again, everybody.
Thank you.
Thank you. Thank you.